Specific yield is used to describe how water drains out of porous media. And to see how this works, let's take a look at this example up in the upper right-hand corner. So what I'm showing here is some porous material here. Let's see, there. And I have it drawing it back here with a perspective to give it a kind of a 3D look. So there's a volume of porous material, and it's saturated, and the water table we can imagine being right up here, indicated by the triangular water table symbol. And so what I want to do is imagine that we have say a container like this, and we put a hole in the bottom of it and we allow the water to drain out. That's going to cause the water table to drop, and we put a container down here to catch the water. So here we see the animation where the water is draining out, the water table drops, and we get some water accumulating in this container down here. Okay, so we have now water that has drained out of the porous media, and of course not all the water is going to drain out. There'll be some water left up in here that's retained in the porous material, and it doesn't drain out, so that porous material will be slightly contain some water. All right, so here's the definition. Well, here's the quantity. There's the volume that's drained by gravity, and there's we'll also be considering the volume of water up in the porous material that is retained in the material and does not drain by gravity. So the specific yield is the ratio of the volume that has drained by gravity, this volume, to the total volume of the material. So it would be that volume there. That's the definition, and we can also then have another definition that uses the ratio of the volume that's retained in this porous media, the volume of water that's in there, to the total volume of the region here, this volume here. Okay, so that's the specific retention. Now, if we add those two together, the specific yield and the specific retention, then here's what we're doing. We have the volume of water that is drained over the total volume, that's the specific yield, plus the volume of water that's retained over the total volume. That's going to equal the volume drained plus the volume retained over total volume. But the volume drained, the volume that drains out plus the volume that basically doesn't drain out, that's retained, that's the total volume of water in the porous media. And if it's saturated, then that's the volume of the pores. So this is just going to be the volume of the pores over the total volume, which is the total porosity. Okay, so there we go. If we add together the specific yield and the specific retention, we get the total porosity. So we can see from this that the specific yield and the specific retention, they must be less than the total porosity, or perhaps equal, but essentially some water is going to be retained on the porous media after drainage. So if this is not zero, then the specific yield has to be less than the total porosity. Okay, so there's our animation. The sum of those two is the total porosity. Now, we also can recognize that the total volume of the aquifer drained, that's shown up here, that's the cross-sectional area, or the plan view area, there I've marked it with A, times the distance that the water table has fallen, which is delta H. So the volume of the aquifer that has been drained is A times delta H. So that gives us an alternative definition of the specific yield, that is the volume of the water drained by gravity divided by the total volume, which is A, and the amount that the water table has dropped. Here's some typical values of specific yield. You can see for gravel, the specific yield is quite similar to the porosity. The specific retention is very small, and so when we drain gravel by gravity, almost all the water drains out. Coarse sand, medium grain sand, a specific yield is similar to the porosity, but as the grain size is reduced, the specific yield becomes less than the porosity as more water is retained due to gravity drainage. And we can see that with silt, the specific yield can be quite low. And the specific yield for clay, we can see, is quite low. It's generally less than a few percent. So the specific retention for clay is large, and the specific yield is small. And remember, the specific retention plus the specific yield is equal to the porosity. It can be useful to have a representative value of the specific yield for aquifers. And if we take a look at these materials here, from gravel through fine-grained sand, all these materials may form aquifers, and we see that specific yield ranges from about 0.1 to 0.35. So we could estimate that specific yield would be around 0.2, plus or minus 0.1 or so, and that's a reasonable ballpark for the specific yield of aquifer materials.